Good morning, good evening, good afternoon, whichever time zone you may be. Welcome to the webinar with Triogen as our guest and Kaltimex Energy as our host. It's a webinar on reducing emissions and cutting costs for decentralized power generation. I'd like to introduce you to our speakers today. First is Mr. Henning van Barsewich, who is the CEO of Triogen, currently in the Netherlands. He has a dual degree in engineering and business administration and joined Triogen about 7 years ago. He's lived in Europe and the United States, and his career journey started as a strategy consulting, and he worked in tech companies in the wind and solar energies in Europe, and his passion is in the energy industry, and thus he's interested in driving the growth of innovative technologies to a commercial scale. Our host is also KK Ralhan, who is the founder and chairman of the Kaltimex Energy Group. Kaltimex has been in business for 25 years now in the energy-related sector, and now is moving more towards the renewable energy. So I'd like to give the floor to Mr. KK Ralhan to start us off.
Thank you very much, Purnima, for your warm introduction. And this is KK Ralhan from Singapore. A very, very warm welcome once again to all our viewers in Europe and elsewhere. It's good morning, good afternoon, good evening. I know the farthest from us is in New Zealand, and very, very late good evening to Mr. Chris as well. I will lay out the format is very simple. I'll give a little introduction of our activities, what we do, and I might spend about 3-4 slides and about 7-8 minutes. And then I will pass on the screen to my friend Henning van Barsewich, and then he will keep you excited for the further 20-odd minutes. And the best part of the entire webinar, of course, as it is, as always, in any webinar, it's a question-answer session. So after both of us have finished, we will leave the floor open for the question answers. As you know, you're all muted, so I will encourage one and all to start writing your questions at any stage of this presentation, and we'll be happy to answer between me and Mr. Henning whatever we can answer, and if we cannot, we will certainly give you the answer to your emails. So with that format, please allow me to start with the Kaltimex introduction, and then we will move in this format. The total time will be around 40-45 minutes. History of Kaltimex Energy. We were established in '96 in Indonesia, and we were the first IPP in the private sector way back then. And ever since, we have installed close to 900 megawatts in Indonesia. Our business model had primarily been representing the world-renowned power generation companies and their products, and we started to dabble into the rural electrification way back in 1999. As you know, Indonesia is an archipelago of more than 17,500 islands, and so rural electrification was the buzzword at that time. We were operating in the diesel and the gas power stations, but our love for the renewable energy started almost like 5 years ago, and we started to go into the cogeneration and trigeneration, and as well as energy efficiency, which we still continue to do, and the renewable energy as well. And because of that, our vision of going into the renewable energy side, we started to represent some of the choicest brands of the various products, Triogen being one of them. If I may just draw your attention to the bottom right-hand side, we have got almost like 25 years of experience in operation. We should have celebrated our 25th anniversary this year, but pandemic won't let us do that. And I'm not sure when we'll be able to do, but whenever it is, we will certainly take that opportunity. The group human asset is over 300 people, and we have got 100 megawatt gensets ready to be deployed at a short notice in whichever part of Southeast Asia we can, especially in the steam turbines business. In Indonesia, we have got more than 310 megawatt installed. Within the group, if we see that our installation base is close to 1,800 megawatt. On the left-hand side, of course, many of you know that 9001 is the management for the quality aspects of the business. 14,001 is for the environmental management. 45,001 is for the operational health and safety. And perhaps many of you may not know that 37,001 is especially the anti-bribery management ISO, and we are very happy to have passed that. We are waiting for the certificate, and as many of you know that as and when these ISOs come or they get modified, the year is mentioned on the right hand side. Next slide, please. I thought this is important for all of you to know our journey with the original equipment manufacturers. We represent Siemens Energy in Indonesia for their steam turbine business. Siemens Energy, acquired Dresser and Ran, which we have been representing for more than a decade. And so when they acquired, we continue to represent Siemens Energy. MWM is a company, as you would know, many of you, in Mannheim, Germany. This company is owned by Caterpillar now, and we represent them in Bangladesh as well as in Indonesia. Voltas is the Tata Enterprise from India, and we represent their vapor absorption machines. And we have close to 10,000, little more than 10,000 tons of refrigeration of their vapor absorption machines installed in Bangladesh alone. But we have the installation in Philippines as well as in Indonesia. Wisman boilers, they are from Germany as well. We have few installations in Bangladesh. We represent them as well. Wabio is from Germany again, and they have the best technology which you can find to produce the biogas from as little feedstock as possible. And we are pursuing some of the very good projects in Indonesia. And right in the center is Triogen. I'm sure my friend Henning would keep you excited once he takes over from me. And we are very proud to represent Triogen. Opera is again in Netherlands, as Triogen is. And Opera has that radial turbine which uses any kind of fuel, right from the flare gases to hydrogen, which is called as the fuel of the future. And we have got its installation in Indonesia, especially in Pertamina, and we are very proud to serve them. Equitech is another interesting technology we have for Southeast Asia, which converts any hydrocarbon, including the municipal solid waste, to synthetic fuel, Euro grade 5, which has got the sulfur content less than 10 parts per million. Biofabric is another technology from Germany we have for Southeast Asia, which is a wonderful containerized units, as Triogen has their units, which converts the white plastic into the syngases as well as the syn crude oil. And HTT is another manufacturer based in Germany with the high range of boilers. And Global Green is, we are pursuing 4 projects with them, from waste to power in Indonesia. And they have the technology from Japan, Korea, and ownership both in Japan, Korea, as well as in Australia. Next slide, please. How we are going to bring Triogen to Southeast Asia? Indonesia with 260 million people and with oil and gas, more than 17,500 islands, where diesel generation is still there, as the mining is a very big sector. So certainly we will be looking at that, as well as we know that some of the power stations run by the state-owned company PLN is still run on the diesel sets. We would like to tap them as well. And Philippines is another country with over 101 million people, which have also more than 7,000 or 7,500 islands, where even we have a project based on diesel, which is bringing electricity 24/7 basis in a very remote island of Mindanao called Bongao Tawi Tawi, with a clientele of over 300 clients. We feel that our networking is pretty good. We can reach people in all the market segments, and we also have the power, the experience in the power generation business, and we can bring that local knowledge onto the doorsteps of Triogen. They don't have to reinvent the wheel, and with our trained manpower, which are mostly technicians and engineers, I'm sure Triogen will find it to their advantage having tied up with us. Next slide, please. This is my last slide. This is to just tell that if you have to tap onto the respective CEOs, we have Mr. Oscar Turalba. He is the president and CEO of Trees, Total Renewable and Energy Efficiency Solutions. His email address is there. Please do contact him for your requirement, as well as we have Mr. Rokhadar Sukada, Mr. Demdem, who is based in Indonesia. He's our Director of Operations. You can contact him as well. And of course, yours truly, you can contact him for any of the other, the 3 countries which we have mentioned will be at your disposal, and we'll be happy to take on your inquiries. I hope you will be starting to write your questions, or you can write down any time. So this is all from me, and I know you have been waiting to hear from my friend Henning on Triogen, what Triogen does. So without further ado, without taking further your time, let me hand over to Mr. Henning von Barsowich, and he will keep you entertained. Over to you, my friend Henning.
Thanks, KK. I very much appreciate the warm introduction. I also really appreciate the opportunity of using this platform. Thanks for organizing that. Thanks for setting it up. And it's really our great pleasure to be working with you. It's been fun so far. So today I want to tell you a bit about power from heat. Our tagline is Triogen. That's really what we do, and how that relates to Southeast Asia, and how it relates mainly into fuel saving technology. Obviously, you can use our technology also in other applications, but today is mainly around fuel saving and what it means to remote power generation. Next, please. So what you see in the bottom here is basically the conventional way that power is generated on remote locations. It doesn't matter where you are, whether in an island in Indonesia, or you're in a mine site in Africa or in Australia. If the climate is roughly the same, you'll always see the same construction, an open shed, power generation, and the diesel engines, sometimes also gas engines, churning away and producing power. Now you can say in the old world, basically there's nothing wrong with that. It just works. It's a proven concept. I think there's a couple of strings attached to it that we like less and less. And so the world is changing. It's changing in the context, first of all, in terms of energy cost, because the truth of this is this costs 3 to 5 times as much per kilowatt hour as centralized generation cost. So if you live in a bigger power grid, you pay a fraction of what you're paying for on these remote sites. So there's a cost issue. That's big cost for mines, also big cost for just remote power generation for islands. Secondly, next one please, is the fact also that with regards to energy efficiency, this is just horrific. And I think as business people and business leaders, we all know this cannot continue as is. So we see we see from outside that there's pressure to reduce emissions. Investors are leaning on big corporates. Consumers are asking for it. Governments are asking for it. But I think also as business leaders, we know that this is not the way to continue. It has been right in the past, or there was no alternative in the past, but things are changing. There are other options available, and we cannot continue like this if we want to take our climate and our environment serious, and we're just hurting the environment that we're living in. But next one, please. It's changing, but these choices are very, very tough to make, because you have to get away from an approach, a cookie cutter approach, which basically churns out the same solution for all around the world. You have to look at the local resources. So whether you can do wind, whether you can do solar, how you integrate that with batteries, what you can do with hydrogen, hugely, hugely site dependent, hugely resource dependent. And there is not one clear answer how to cut it for every site. So many of you will be wrestling with those questions and will have them in your mind. And the question is, yeah, that's all nice. Look, I can work on a wind project, on a solar project. It takes years to develop. It's major capex, and it's still venturing somewhat in the unknown. And what we can do as Triogen here is we can help with the existing setup that you're running today. So we're not talking about the long-term pie in the sky solution, but something that actually is real, practical, and doable today. Next slide, please. Because what we do is we offer a fuel-safe solution that you can combine with diesel gensets, gas gensets in the 1 to 3 megawatt range, roughly, to give you an idea. What you see in the picture here is on the left you have a genset, and the right as well in those containers. Those happen to be 1 megawatt gensets, so give the total power conventional generation installed here is around 2 megawatts. And what we can do is we can combine that. We can combine the exhaust gas from those two engines. You see, normally it goes to the stack, the vertical pipe that goes straight up from the container, and that's it. Goes out to the birds with 500 degrees. What we can do is we can take the exhaust gas into our machine. So what you see in the middle, those two containers, that's our equipment. So we take the exhaust gas, put it through the top container, which is nothing but a heat exchanger, conventional heat exchanger. It evaporates our working medium, and rather than escaping with 500 degrees, it goes to the ambient air with around 200 degrees. And we then run the vapor that we produce through a turbine, which is at the heart of it, it's the same as any conventional power generation, as any steam turbine. There's a few tricks why we can make it so compact and so small and put it into containers. It's called ORC technology, so it's an organic working medium. But that's just basically the magic within the system. At the heart of it, it's a turbine that drives a generator that produces power. And you can see on the yellow side of our container, where it says e-box, that in the back there's 2 power cables coming out. So basically, that's where we put the power back into the grid. We synchronize it with the local grid. Nothing special about that. The whole installation is also pretty simple. You can see that basically 2 pipes going in, an internet connection, a power connection going out, and we also need an internet connection. And that's basically it. We have our built-in cooling that's in the back of the top container, and that basically is enough to run the overall system. So integration, pretty simple. We'll show you a little animation of how this works to give you a bit more of an overview. So this is us, Power from Heat, Triogen, a Dutch company, you mentioned that. So this is a conventional way that power is generated. Diesel gensets, gas gensets, and that's the world that we're coming from. Trouble is, only 40% of the chemical energy is converted into electricity, 60% is wasted. Means 80 fuel trucks go into a 2 megawatt power plant that runs 24/7, the majority of it actually is wasted. But in our solution, mentioned this to you already. So there we use, instead of the 500 degree, the heat goes into our system, goes out with 200 degrees, and the generators don't have to produce 2 megawatts. They only have to produce 1.85 megawatt, roughly. And that produces the load. It's easy to ship, it's easy to install, it's easy to connect, so it doesn't interfere with the production, doesn't interfere with the running of the engines. It's internet connected, so we monitor it, we know exactly what's going on, and yeah, we have a very good grip on that technology. Next one, please. There we go. So with regards to, you'll obviously, one of the questions is this novel technology? In a way, it's innovative, but it's also proven. We've been doing this for over 10 years. We've got over 1 million operating hours in the field in some 15 countries, over 55 installations. So trust me, we've learned our lessons. There's some things that we've learned as well that we didn't want to learn. That's business, that's life. But we've moved on and gotten stronger from it and know how to deal with it also on challenging sites. It's also easy to operate and easy to run. On the installation side, the containerizing clearly makes a big difference. It's a step that we've done a couple of years ago to put the unit into a container. Very happy with that choice because it really makes the whole installation much easier. And importantly also, is it doesn't have implications on the engines. So it's easy to operate. It's got a fail-safe mode where basically if the ORC is down because of maintenance or God forbid because there's an error on it, the generators, the engines can continue running normal as is. They don't see any difference. The default setting is that the flue gas escapes and doesn't have any implication on the engines. And it's also easy to operate. I think with regards to, there's no need for specialized staff on site. The people running the site, running the engines are plenty capable of looking after our equipment. It's pretty simple when you compare to a generator which needs oil change, filter change, lots of moving parts in there. What we do is super simple and super banal, if you will. What you have to deal with as an operator is simple work to look after it, and it fits within the overall topic of the energy transition. You can call it climate change, whatever context you give it, but we all know it's changing. Everybody is on this trajectory to change, to doing things differently, and what we can offer is a reduction of between 5 and 10% of emissions per kilowatt hour. You can roughly say that one of our containers saves 350,000 liters of diesel per year. 5 to 10% savings. The reason for the range is because it depends on the engine. If it's a super efficient engine, it might only be 5%. If it's a kind of middle of the run, it might be 7%. And if it's not in a great shape, it might be 10%. Because basically, yeah, the less efficient the engine is, every kilowatt hour that we produce saves more fuel. And you can, in terms of quantifying it, not just in fuel savings but also in carbon, we're looking at some round about 950 tons a year per ORC. And the benefit of it is not just financial, not just environmental to the air, if you will, but also it makes running sites easier. Because if you can cut the number of fuel trucks or ships that have to arrive by 5 to 10%, it makes a difference. It means that your built-in storage lasts longer, and there's less risk of transport and less hassle of the transport. And many sites, it's also the hassle of transport is a big factor. And it also finally deals with the sustainability development goals of the United Nations. So it also ticks the box on the green side, clearly. Next one, please. Yeah, great that there's all these green benefits, but let's talk money. Simple payback, just to give you an idea. This is a simple calculation where we've only taken into consideration the fuel savings. So not looking at any easier operations, at lube oil changes, at filter changes of what have you, of reduced running hours. This is purely the payback in years based on the fuel saving. And you can see that if you're a bit more on the right side with 8,000 running hours, you're always in the green zone where you're between let's say two to 2.5 years at the prevailing oil prices between 60 and $80 a liter. And yeah, these are the prices today. We used to see everything a bit higher, but so the payback times have gone up a bit. but the logic still is basically logic is driven of the economics is driven by the fuel price. The higher it is, the better the payback, and also the number of running hours. So it doesn't really make sense to do fuel saving technology is in the standby generation, because you have to kick it in every so often. But if for any baseload application, it's really worthwhile and it's really worth looking at. And I've not quantified in this any beneficial effects of CO2 emissions that may or may not have a value, and other benefits. Next one, please. Which one is it? There we go. To make it a bit more real in what the technology looks like and sort of what our experience is. This is a site that we've put into operation in 2009. What you see in the middle there, the yellow box, that's our equipment. That's the old design, and the heart of it has not changed. It's just that we've containerized it. What you see from, and then it's connected to two Jenbacher gas engines. They're running on biogas. So I sit underneath in this gray building, and you can see on the left and the right out of that little building ground floor thing, coming two pipes. The vertical pipes take the exhaust gas heat into the horizontal pipes, and it goes into the back into our evaporator, and there we produce the power. This is a site that has been producing, churning away some 150 kilowatts steadily over the last 10, 11 years, and a very, very good reference for us, just to give you a feel for where we're coming from, with also a very happy customer. And that can be visited anytime. Then we have a more recent example. This is the fuel saving calculation in the UAE with some KTA50 engines. I've explained this picture to you before, so I'm not going to go into all the details, but that's basically what it looks like when you run it in a very hot climate here in the Middle East. We faced temperatures above 50 degrees, and we still had steady, good operations, and no problems at all. And then finally, a more recent site, which we've put into operation actually just in November this year. This is a nice clean site in Turkey, running on landfill gas. We've connected three MWM engines here to our machine, so we always have plenty of heat that's available to run. Recent installation, and what you can actually see is the container, the gray container with a yellow stripe on it. That's probably by now familiar to you. That's our unit. That's the heart of it. That's the ORC that we call the container. We call the E-box. On top, you see the table cooler, and to the right of it, the shiny aluminum-clad equipment is our evaporator. So what you've seen in some other pictures on the top as a container can also be separated. It doesn't have to be in one unit. What is our standard scope of supply certainly is always the bottom container, because that contains the turbine, the control cabinet, everything that makes the process drive. And the two heat exchangers can be in the top container in the T box, or they can be separated next to it. What you can always, so that's the standard scope. And then we always have an element of tailoring to the site, in your case together with Kaltimex, of adapting the piping. That is a custom job. The piping, the valve, doing that design, doing that engineering is always a customized exercise, whereas the rest, the containerized unit, is a standard piece of equipment, and it doesn't matter to us whether we ship it to a site in, let's say, Finland, to Australia, or to Asia. That container will always look the same. The one difference may or may not be whether we put in an air conditioning unit that will not be needed in Finland, but other than that, it's the same equipment. And I mentioned earlier to you the complexity of dealing, the tough choices as operators. What do you do? What's the technology that you put in? Now, solar, solar is clearly, PV is something that really is coming up and strong and becoming increasingly cost competitive. Many of us will have it on our roofs. I certainly do, and it's a great thing to do. We've put it here in context with the help of an external consultant. and compared solar and solar with batteries with our technology. And the key takeaway is we can save in the middle of the road scenario some 7% of the fuel. If you go to solar PV, you can go up to 14%. If you combine it with batteries, you can go up to 30%. There's a caveat to it, and that is that the cost of the equipment of the investment goes up as you move further to the right, and you can see that in the payback times below. In this case here, we have a payback time of 1.6 years. Solar PV with the same assumptions is just above 2 years. I think it's 2.2 years, and PV plus batteries is approaching the 3 years. Now the takeaway from this is not an either or. This is actually something to combine. This is something to do together, because at the end of the day, we're all on this journey towards making energy supply more sustainable and making it more economical. And certainly a payback time also of 2.9 years, something that gives you a very handsome IRR, not to be sniffed at. But you can combine these technologies, and so you can use the exhaust gas heat of the existing engines, convert that into electricity whenever the engines are running, and when the engines are not running because the solar PV is running, great. Then there's a saving from that side. It's true that there's a bit of cannibalizing effect, that if you have 30% produced by solar PV, then you're producing less power from our equipment because you're also producing less power from the gensets. But hey, we're looking at a 1.6 year payback time. If that then goes up to 2 years, I think it's still a very interesting and very attractive investment. So it's takeaway from that is it's not an either or, but it's an and. It's all compatible and all fits together on the same journey that we're on. Next slide, please. And so as a key takeaways, it's a product that's proven alive. We've done this before. We know how it works, and it's ready to be deployed. It's simple to install. It's simple to integrate. It's a certified technology, so for autonomous operation, we've won some awards with it. So it's real stuff that is there. And next block, please. It gives you a fuel savings. You save up 5–10% of the fuel, payback 2 years, around about 2 years. You can say in simple numbers, one of those e-boxes saves you up to 350,000 liters of fuel in a year. Easy to install, easy to operate, and compatible with also future technologies. And yeah, that's it for our side. Now over to KK and to also any of your questions. And yeah, if our partner in Southeast Asia is Kaltimex, and very happy for you to fire all your questions towards Kaltimex, and well, for now to us, and then later on you can reach out to Kaltimex and also to us directly.
Thank you. Thank you. Thank you very much.
Thank you very much.
The question is, I will read it later, but I have one question myself. The question is that which was the Turkey installation, and you had the landfill gas. Now, landfill gas must be, but still, Turkey made an investment of putting the e-box and generating 155 kilowatt. Henning, could you please tell us that what was the payback for that system?
I think there's somewhere around the 3-year payback range, if my memory doesn't fail me. But something in that order of magnitude.
Excellent. I think this was very interesting, and I wanted to pick up because our views from Bangladesh as well as from Indonesia, I think I wanted to highlight to them that, and that installation was for MWM engines. Now I've got a question here. I think you can answer that. Can this system be installed in the biogas and natural gas gensets also?
Yeah, and it's perfect. Yes, very fair question. Absolutely, the answer is a straight yes. No reservations, nothing whatsoever. Works just as well. It's not just a diesel technology, but also works very well. We've got actually in Europe a good share of our projects in Europe are running on biogas. So some 30 machines running on biogas. Natural gas is the same. For us, basically, you can really imagine it as converting a waste heat into electricity. And whether the waste heat, we actually have different applications as well. We can also do it with biomass, but I think that's a topic maybe for another webinar. Let's park this for now. But there's different technology or different heat sources, but it doesn't matter what the heat source is, as long as it's reasonably clean, we can live with it. We can put it through our heat exchanger and we can convert it into electricity. So absolutely, if you have biogas opportunities or natural gas opportunities, please reach out to your counterparts within Kaltimex, and yeah, it's a great opportunity.
Right, Henning, there is another one which I think is a good question as well. What is the expected lifetime of an e-box in terms of operating hours?
Fantastic one, I love it. Well, 15 plus years is what we say. I mean, we've got some equipment that's been in the field for 11 years running without problems. And if you look at it as an engineer, it's actually pretty simple. It's largely heat exchangers. There's a couple of valves in there. There's some rotating equipment in there, but rotating equipment also is not difficult to maintain. You need to do some, provided you do the right maintenance. When you compare it to an engine, it's almost got an infinite lifetime. Because with a bit of maintenance, you're not wearing out anything. Rotating equipment is known to last for very long times. Steam plants run for 40, 60 years, no problem. And inherently, so far, because of our limited operating experience, it's called like that. We say it's 15 years, but actually from an engineering point, and the longer we've been doing this, the harder we think about it. There's no reason why it shouldn't be running 20 years or more. And that's with minimum maintenance. When you think about an engine block, it just wears out. The cylinder, the pistons, it just wears out. That's not the case with our technology. With a bit of maintenance, simple maintenance, then it's all done.
Excellent. There's another question, Henning, for you. What is the minimum flue gas temperature and the flow rate required for a 150 kilowatt e-box?
Fantastic. I see that we've got some people that are real experts in the field in there. Our minimum temperature is 350 degrees. Below that, it's just not the right technology. We have a high efficiency solution, and so we need a minimum of 350 degrees Celsius. With regards to the minimum heat, basically look at it. In order to produce full power, we need around a megawatt of heat intake. That can be from two gensets with 2 megawatt. If you go to the highly efficient latest spec MWN engines, you're probably approaching the 2.5 or 3 megawatt that you need in terms of heat input, but that's roughly what you're looking at.
Thank you. Henning, there's another one that you mentioned about the play and plug. How much time it takes to put up the e-box, say for 1 megawatt set?
Oh, that's the benefit of containerizing it. It's a matter of 2 to 3 weeks. 2 to 3 weeks, you're done. Basically all you need to do is load those 2 containers, stack them on top of each other, put the power connection in at 400 volts, and do the piping connection, and that's it. Integrated with the overall control system, and there you go. So 2 to 3 weeks, you're done.
Right. I think our viewers are looking at your slides with interest, because there's another question that you had mentioned 950 tons of CO2 saved per year. They want to know that was for how 1 megawatt or half a megawatt or 2 megawatt?
That's for one of our system, typically running in combination with 2 megawatt power generation side. So that's one of our e-boxes running full blast year out. Right.
Henning, somebody has asked, have you got any installation in Southeast Asia?
That's why we've got this call here. That's why we eventually got this together. We've got something in Australia, but we somehow skipped Southeast Asia yet so far.
I think we'll be glad to put. I hope my own team is motivated, because what you mentioned, what we saw in the Turkey, that even in the landfill gases, where the gas price is nothing, and then you can still produce more electricity, and payback period was 3 years. And so if that can happen, because we have close to 900 megawatt in Bangladesh and close to 475 megawatt in Indonesia, and that talks about, of course, it has to be 24/7 basis. There's another question. How does your system compare with the conventional CHP, combined heat and power?
That's a great one, because there's one benefit that we've not mentioned. So CHP is different, as in different worlds has different meanings. So in some countries, especially the UK, the CHP is typically, what people mean with that is the generator, is the genset, because you can produce power with it and you can produce heat with it. We do a bit the same thing. We need the heat we need a waste heat source, but we also produce power and we produce heat. And I've only talked about the power side in the Southeast Asia context, but it's fair to mention as well that we're also producing heat. You might remember on the picture from Turkey with a big table cooler sitting on top of the e-box. That is our heat rejection. Now we don't need to reject that heat to a table cooler. We can also, that's just to make customers' life easier and not to require them to provide us with cooling. We might as well, and in many cases we do as well, provide heat to the site. For example, to biogas plants. You have a need to heat the digesters, for example, or you might have drying purposes or what have you. So we do have cooling water that is available from our process. And if you're smart and you make the most out of the energy, then you're not only using the electricity, but you're also using the heat. So in that sense, it's absolutely it is a CHP solution what we're doing.
Right. I think there's another one, that what will be the delivery of your e-box for, say, 2 megawatt sets running?
The power output?
Power output, I think you mentioned 155 or 150. And what will be the delivery time for supply? I mean, giving that e-box, that's your total system.
Yeah. Well, lead time is somewhere between, depends a bit, 4 to 6 months. Depends a bit where we sit, how busy we are in the factory, but that's roughly what you should be expecting.
All right. I think I'm ready to take one more question, because we're coming at the end. Please do. Time for one more question. There it is. I was wondering why it has not come before. I think the question is, how much will it cost to put up an e-box for 1 megawatt? I think 1 megawatt is a fairly standard one.
Yeah, typically we like to combine it at 1 megawatt. You will not be running at full capacity, so the advice is typically to combine it with, let's say, 2 megawatt, and it's site dependent. I would leave it at that. Say site dependent. Economics, very happy to talk them through, but rather than giving one approach, I mentioned that cookie cutter doesn't always work. Happy to look at it. You can see, you've seen the paybacks, you've heard the paybacks for Turkey, so it's always a worthwhile case. But just mind you, it's not worth falling into the trap of throwing prices across the fence when they're just not reliable. We need to understand a bit more how many engines, what's the connection, what are the distances, how do you fit it into the overall plant design, and then we can do that. And our friends at Kaltimex, you guys are plenty capable of doing that. And I would encourage you, for your questions, especially on the economics, for anything more site specific, please reach out to Kaltimex. And we'll come up with a good pricing for you when we have a good understanding of what the site roughly looks like. Excellent,
Henning. I think you have certainly left me excited, because with so many megawatts, the blue engines, we love the blue engines, as you know, that we represent MWM. I hope our team is charged as well as our other viewers, other clients. And once again, my very special thanks to all the viewers to find the time to attend this webinar. Thanks to you, Henning, for taking your time out. I know it's early morning, temperature may be dropping down there. And thank you for all others, and thank you to our friend in New Zealand as well for coming in. And once again, on behalf of Kaltimex team, thanks to Triogen for choosing us, and we remain grateful. We'll do our good job. And thanks to my colleagues who have made this possible. Thanks to the IT team who have been working assiduously behind the scenes. And once again, I would like to take this opportunity to wish all our viewers, including you, Henning, and my other colleagues, if they are watching it, an absolutely super holiday season, super Christmas. I know among all this pandemic which is there, but we have got to make best use of it, what we have. And I also wish to everyone a fabulous 2021. I know 2020 is that ready to be consigned to the history books. It will certainly go there. But let's hope that let's ring in the new, that 2021 would be a good year for everyone. Meantime, all of you, without exception, please stay safe. Please stay well. Thank you very much.
Thank you also from my side, KK. It's great to have this forum, and a real pleasure to be working with you, and I'm wishing everybody around the world, wherever you're dialing in from, have a great holiday season and a fantastic start into hopefully smoother running year 2021. Take care.
Thank you.